Welcome to part 2 of one-to-one functions. Just as a reminder, a function f is one-to-one if different outputs, which usually means the y value, always give different inputs, which means the x value. And if you remember from part 1, this means that the function f must pass the horizontal line test for it to be one-to-one. Now, that's with a graph. But what if I gave you something like this table? Let's look at number 1 over here. We'll call it number 1. Looking at this table of just 3 points, we're giving you x values and y values. F of x is our y value, just in functional notation. The question is it one-to-one? Is it true that for every output, there's only one input? So let's look at the outputs. The number 3. Number 3 gives a 2. Is there any other place where 3 gives a different value? The answer is no. Let's look at 6. Is there any place for this y value of 6, which gives a 4 here, gives another value? No. Don't be fooled by the 6 up here. That's an x value. Let's look at number 7. 7 gives a value in this function of 6. Is there any other place where 7 gives a different value? And the answer is no. Since there's only 3 points in this function, and they all 3 pass our definition of what a one-to-one function is, this is a horizontal function. I'm sorry, this is a one-to-one function. So we will write one-to-one. Okay, let's look at the second example. Let's look at, in this table, number 5. 5 gives a 1. When y is 5, x is 1. Now, is there any other place in the table where when y or f of x is 5, it gives a different value? And it sure does, because you'll notice right over here, 5 also gives a 3. Okay, so if I were to actually try to graph that and graph the point 1, 5, let's do that right here. There's a 5. Here's the point 1, 5. And then I also graph the point 3, 5 right there. There are the 2 points, 1, 5 and 3, 5. Notice they would fail the horizontal line test because for one value of y, you're getting 2 values of x. So therefore, this indicates that it is not one-to-one. Not one-to-one. Let's look at our third problem. Let's get a better look at it. Over here. Let's make it a little bit bigger so we can see it. And the question is this a one-to-one function? And you'll notice that it fails the horizontal line test. Because if we pick almost any value for y, like this 3, it will, if we draw the horizontal line, there'll be 2 values for x. Here's a value for 2. And if we do the horizontal line test, it'll have 2 values for x. And if it fails it even once, it is not one-to-one. So this one is also not a one-to-one function. So not one-to-one because it fails the horizontal line test. Okay, but what if we have a function like this and we really want it to be one-to-one? Well, what we can do is restrict its domain. If you remember, the domain is basically all of its x values. So how can we restrict the domain of this so that the function is one-to-one? Well, what we could do is we could say, why don't we just say, as you can see here, the domain is, you should notice this is all real numbers. All values of x are valid. What if we want to restrict it to say, let's make the domain restricted to some subset of all those x values? One obvious one might be all positive numbers. So let's make the domain x greater than or equal to 0. What that means, if I draw it on the graph, I'm going to outline all the values on this graph for which x is greater than or equal to 0. And you notice, there it is. Now, if I only look at that part of the graph, you will notice it passes the horizontal line test. If I were to draw any line through a y value of 1, it'll only intersect the red line in one spot. For every y, there's only one x. Okay? So therefore, by restricting the domain to be x greater than or equal to 0, this is a one-to-one function. So we can now say, now it's one-to-one. Now it is one-to-one. Now, we didn't have to restrict it that way. What if we decide to restrict it this way? How about if we make x values all negative? So we could also say restrict the domain so that x is less than or equal to 0. Notice once again that this would pass the horizontal line test, because for every y value, there would just be one x value. So in this case, now it is one-to-one. And actually, there's infinite ways of restricting it. We could have just restricted it to be all numbers greater than 2, or all numbers greater than 3, or all numbers less than -1, and it would still be one-to-one. So we are allowed to restrict the domain of a function to make it one-to-one if we need to. And so I hope that is clear. And so now it is your turn. So there are 3 problems here. The first 2 are determine if each of these functions is one-to-one. I give you 2 tables, one here and one here. And finally, I give you a function down below where I ask you to restrict the domain so that the function is one-to-one. If you have any trouble with this, just go back, rewind the screencast, see how it how we do this, and hopefully that'll help you. So good luck, and see you again next time.